Hey everyone, welcome to episode 3 of deploying Nomad on Google Cloud. In our previous episode, we deployed a load balancer to be able to expose the Nomad UI. In this episode, we are going to deploy a load balancer that acts as an ingress proxy to expose different services that we deploy in our Nomad cluster. I'm accompanied by Chris, who also helped me in episode 1 and 2, setting up the Nomad cluster and the load balancer to expose the UI. Chris, you want to say hi to the audience?
Hey everyone, what's up? Glad to be here again, and let's deploy some actual services to our cluster. Yeah?
Exciting. So what are we going to do today exactly?
Yeah, so we now have a cluster and we can reach the administrative dashboard. And that's all fun to see, but it's not very useful, right? So I think it's time we start deploying actual applications for users. I think we have a little HashiCorp provided sort of Echo Hello World app that we can use as an example.
Yep.
And in order to make the whole thing work, we need to deploy the app. We need to make sure that, which will be a Docker container, by the way. So we need to make sure that Docker has proper networking. So for that, we need to install the container networking interface driver. We want to deploy a proxy so we can do some load balancing and routing within our cluster if we're going to run multiple services.
Mm-hmm.
And we need to deploy yet another global load balancer on Google that points to our proxy, so we have a way in from the internet.
Yeah, awesome, cool. And what are we using to proxy our traffic?
Yeah, so very nice that you already say the word traffic here. So there's a couple of options for this, and I personally really like traffic, spelled a little bit differently than the English word traffic. It's fairly simple. It's basically just one container you run, and it's easy to set up with applying tags to your services in order to give them proper routing and middleware. And it's very well documented as well. There's official support, so yeah, we're going to use traffic.
Exciting, yeah. And I believe traffic is one of the few proxies that actually has native support for Nomad built in, which is awesome.
Yeah,
we're going to show you guys how that works, and let's get started.
All right. Yeah, so I think the first thing we need to do is get that networking interface driver configured.
Nice.
Here
So
we have some
we're going
code.
to install the CNI, right?
Yeah, so containers, if you want to use networking other than standard host networking, which in an environment like this is not a good idea because you will run out of ports and you don't want to expose every port on every host.
Yeah.
So we're going to need some bridge or overlay networking. So in order to make that work, we need to install the container networking interface driver for Docker. And that needs to happen in our Cloud Init configuration.
Yeah, because every instance that we boot up, every Nomad agent needs this CNI installed.
Yeah.
So if you remember from episode 1, we had a Cloud Init file to be able to bootstrap our Nomad agents. We're now going to add a new init script to install, to actually download the container networking interface plugin, the CNI, and then we're going to unpack it and have it on our machines. Yeah, let me go ahead and write that out. So we're going to create another opt-init. Let's call it like install CNI.
Sounds good.
Permissions going to be the same as the others.
Yeah, so script we need to be able to execute it indeed.
Yeah. Curl LOCNI plugins.tgg. And then we download it from the GitHub project.
Yeah, so there is an official release on the container networking group.
I'm sticking with their first stable release. Is that okay?
Yeah, that should work fine.
So that looks fine, I think. Curl LO. I'm going to create a directory to dump it in opt. And then
So this is a little bit of magic, maybe, but if you put this binary in opt CNI bin, Nomad will automatically find it as well and make sure that all the servers that have this plugin installed are properly tagged as supporting container networking.
yeah. If you scroll a little bit down, Chris, what I'm going to do is in run cmd, next to our existing init and install Nomad scripts,
Yeah.
we're going to add the install cni.sh. I think this should be fine, actually.
Yeah, this is all we need to get the networking for our container environment up and running.
Yeah.
So should we go and apply this?
Yay.
And this will, of course, cause a change in our instance template again, meaning all of our instances will be replaced. But since this is one-by-one action, this should never have any, or should never cause any disruptions to any service that might be running already.
Yeah.
So the template is there. It's now changing the actual instance groups.
Yep. And is it maybe a good idea? Could you explain to the audience what the CNI does for us?
Yeah, basically, in a container environment, your containers run on a host VM in a container runtime like Docker.
Mm-hmm.
And out of the box, the only networking they can do is networking provided by the host. So that's host network mode. That works perfectly fine, but in an environment like this, where you are going to run multiple containers on a single host, and it scales up and down and it's very dynamic, you're going to have issues when you have, for instance, 3 or 4 instances of a service running on multiple hosts. You want to route traffic. You need all of them to be on the same port. You're going to get issues with IP addresses and ports very quickly. So instead of doing that, we're basically virtualizing the networking. There's a couple of modes, bridge and overlay, the Docker supports. And in order to add that support to Docker and Nomad, we need to install this driver to basically implement the CNI, which stands for Container Networking Interface.
Yeah. Okay, thank you, Chris. I saw that we actually finished the apply, by the way. So
yeah, it's all done. So if we go back to the Nomad UI we had before, we should see some action on new servers and clients being provisioned. First in Google, this needs to happen, and then when a VM is actually up and running, only then it is added to the cluster. So we'll keep a little eye on this, but we can already see in Google here that a bunch of new VMs have been created. So I think it's going to be fun.
Nice. Awesome. So our next step, once the CNI is installed, would be, I'm going to assume, setting up Traefik as a system job, so it runs on every Nomad agent. Is that correct?
Yeah, so to be able to route traffic to multiple instances of our service, if we want to scale up, we need to do load balancing, we need some routing, we might need some path, URL mapping, these kinds of features. So this is where the Traefik Proxy service comes in. So that actually just is deployed as a job in Nomad, like any other service you might want to run. And you're right, we're going to tag this as type system, which you will see in a little bit. And that means that it will run one instance of this job on every client. It's comparable to like a daemon on Kubernetes.
Okay. Exciting. Yeah, should we go ahead and set up our first Traefik job?
Yeah, let's do it. So we don't have CI/CD for applications yet. That will come at some point in the future in this series. So for now, to create a job, we actually need to go to the Nomad UI and go to jobs and run a new job. But I don't want to lose the code here. So I think it's a good idea to at least write out the job template in our repository.
Yep.
And then we copy it over here once. And then in the future, then it's also easy to incorporate it into our application CI/CD.
Yep. We should definitely do a separate episode on CI/CD for Nomad jobs.
Yeah.
Cool. I went ahead and created a little folder structure with jobs, subfolder system, and then a traffic.html.
Very good.
Just gonna start writing out the template. If I make any mistakes, Chris, feel free to correct me on the fly. We're gonna
live
editor together. I think we used the GCP EU before.
Yeah, so we only have one data center, so this wouldn't have that much of an effect. If you have multiple data centers, this would be the place where you specify where your job is allowed to be run. But it's, I think, a good habit to type it out here anyways.
Yeah. And could you explain to the audience what the system job actually is, or what it does, and how it differs from other jobs?
Yeah, so this other jobs, basically, depending on your scheduling constraints, the instances get spread out over your clients. Whereas a system job, it ensures that there's always a single instance of this job running on every client. Never more, never less. In our case, this is important because we are going to deploy a load balancer pointing to this service as an entry point in our entire cluster. So we need it to be on every VM on a predictable port. Otherwise, we can't target our instance group as a backend in our load balancer.
Yeah.
So for ingress kind of gateway type of services, this is the recommended networking setup.
Yeah. It's a bit annoying, perhaps, if you see me type this out. For some reason, I don't get any formatting. So bear with me, please.
You're probably missing a couple of brackets. That's why it's not formatting.
I was assuming I did not.
You can run a format. It's not there, so.
But I'm not sure if you have an HCL, if your editor detects HCL.
Yeah, it does. Yeah.
Oh, okay. I'll just continue to write, and you can fix things. That's network group surface. Maybe you can explain to the audience what I'm doing and why I'm setting up the HTTP service as well as the dashboard server, Chris.
Yeah. I don't think we need a dashboard though.
Okay.
It's nice to look at, but it's not terribly useful.
We'll get rid of it.
We just need a static HTTP port to receive all the ingress into our cluster, basically.
Yep.
So about the job spec, it's all documented on the HashiCorp website, of course. But basically, we define a job, which you give a unique name so you can recognize it. You type out where it should be scheduled. You can set some constraints for updates. So in this case, only one gets updated at a time as a rolling update. So we never have any downtime on our cluster ingress, which you definitely don't want. And then within a job, you can have groups. And a group basically packages network, service, and task configuration as a deployable unit. For networking, we expose this on our host on port 80, and we point it to the container port 80 as well. And because we do this on every host, and we select our instance group as the backend target of our load balancer, any request going into our cluster from the outside world will always hit Traefik first. And from there on, it is routed to our actual user services.
Yep.
Then we define our service, which is sort of our entry point. We tell it, we give it a name. We tell to target this port, which we defined up here, HTTP, which is port 80. This way you don't have to remember 80, but you can use named ports. We select Nomad as our service provider. You can also use Consul, for example, if you want to do more complex service discovery types of situations. We don't have Consul installed, so we're just going to use Nomad to keep it simple. And then we define our actual task, which is our actual workload, our compute, which is going to run as a Docker container. So that would be our driver. And now we are going to configure which image to run, which ports to open on our image, and which arguments to pass to our image.
Yep.
When we started.
I'm just double checking I made no mistakes. I think this is enough.
Let's have a look. I think we are missing one bracket here.
Yeah, for group. Okay. Though, yes, I think that's correct.
The syntax is all HCL, which is very familiar if you already use Terraform. It's a HashiCorp configuration language. All Nomad jobs are declared in this language as well. So it's pretty easy to switch from one product to the other, not having to switch languages. Yeah,
Awesome.
I think that is it. We have our job, we have the networking, the service, the task. Yeah, let's deploy this, see what happens.
Yeah. And at first, you saw that I was adding a dashboard. Traefik also exposes a dashboard where you can see what has been set up in terms of routing and proxying. But like Chris said, for the sake of this video series, we can just set up an ingress proxy, especially for this episode. We might add it in the future. But for this episode, we're just going to focus on making sure Traefik is able to be routed into the cluster.
Yeah, correct. So maybe a couple notes on these sort of magic variables. So this is sort of a job template, basically, and Nomad injects a couple of environment variables into every job template you submit.
Mm-hmm.
And these are sort of reserved variables. Nomad port, postfixed by the name of the port you specified here.
Yep.
So while this job is executed, this value will actually be replaced by the IP address and the port of our VM and our port declaration up here. So in this case, 80. Again, by templating it and using these variables, you don't have to hard code the number 80 everywhere.
Yeah. No, indeed, Nomad IP stands for the host IP, and 4646 is the Nomad port.
Yeah.
So we want to receive traffic on port 80 and then fan it out to different services with their own ports. Yep. Okay.
So I'm going to paste it in here. If there's any syntax issues, by the way, this editor would also tell me.
Recognize that.
It looks pretty good, so I can plan it. So here will tell me like a summary of what's going to happen. If I already had, for example, a job with this name, it would update it instead of create it. So this looks pretty good. It's not there yet, which we know is true. So let's go ahead and run this and see if it gets deployed everywhere. So we have 3 clients in our VM, which is the size of our managed instance group. We expect 3 allocations here as well, because we have this system job. And we can actually see that it's doing exactly that. We have 3 allocations, which are already running, by the way. It's very fast. It literally just has to download this Docker image and then run it with the parameters. So it goes very fast.
Did we double check that all the instances are updated with the CI?
Yeah, they were already running before.
Okay. Great.
So yeah, here we go to the client's overview. We can actually see our 3 new instances. I know they're new because their IP addresses are higher than the other ones.
Yeah, and there's 6 and 3 are down and 3 are ready.
Yeah, those 3 are down, which is expected because they are removed from the managed instance group after all the instances were updated with our new template. In about 24 hours, Nomad will automatically remove these from the dashboard and sort of consider these hosts completely gone. And that is part of the autopilot cleanup feature. We can also have a look at the topology where we can see what is being actually scheduled. And I think here is a good idea to only have a look at the instances that are actually there. So we can see we have these 3 instances, and each of them have some reserved memory and CPU, and that is actually from our traffic job.
Nice.
So as I expect in a system job, 1 instance is on every client host running. So it looks really, really good.
Nice. Awesome. That means I think we can set up the load balancer to serve the Traefik Proxy.
Yeah, absolutely.
Cool. The jobs seem healthy, right?
Yeah, everything's okay. If they're not healthy, they would not be green. So it's fairly easy to spot.
Yeah. Cool. For the sake of this demo, should we set up a? So in our previous episode, we set up a Nomad UI load balancer, which is protected by identity-aware proxy. For the sake of this video series and what we're trying to demo, should we set up a public load balancer to expose like a Hello World application?
Yeah, I think it's really to always separate, deploy separate load balancers for separate purposes. So in our case, we can set up a separate load balancer for exposing all of our public services that we want to run, which is not protected by identity-aware proxy because we want our services to be reachable by anyone using the internet, right?
Yep.
So let's go ahead and set up another load balancer indeed.
I'll call it like proxy GLB or traffic GLB, maybe. Maybe that's a better name. Traffic GLB. Cool. So I created a new file in the editor, but I think you have it open, right? Yes.
Yeah.
So we start off by reserving a global address for our load balancer.
Yeah, we need an IP address again. Separate IP address from load balancer. So we'll also create a separate DNS entry on a separate subdomain.
Help me out with the resource naming here, Chris. Should we call it the traffic load balancer, or should we call it the Nomad public load balancer, or what is your preference?
I always like to keep names descriptive and not use the name of the actual technology under the hood, because at some point we might decide to change traffic for like Envoy or something else. And then you would have to update all of these resources. If you don't, your other developers might be super confused about what's going on. So I would say Nomad public sounds good.
Just Nomad?
Nomad public.
Oh, Nomad public, sure. Yeah. I'm also going to rename the file. Nomad public GLB. Nomad public. And if you can, as I'm writing out the load balancer, please share with the audience what I'm doing.
Yeah. So we went basically through this entire setup in the previous episode for our admin UI load balancer. So I think we can go a little bit faster this time, but I will narrate a little bit anyways. So yeah, we have the IP address, which we need for setting up the DNS, and we need to put in front of our load balancer. We can also do a health check, which basically points to that port we just defined already in Traefik, which is port 80. So we'll need to make sure that we have a named port on our managed instance group, and then we target that in our TCP health check. By doing this, we make sure that if traffic hits the load balancer, it only is sent to instances in our managed instance group that are actually properly serving our Traefik proxy on this port. So while you're typing out that, I can have a quick look to ensure that this named port already exists.
Right.
It should be there. And this would be on our client's instance group. Yeah, so we already have a named port called HTTP on port 80, so that looks all pretty good.
Nice.
So yeah, as part of our load balancer stack, we have our backend, URL map, SSL certificates, HTTPS proxy and forwarding rule. These are all the resources we are going to set up now. These are basically all the layers of our global load balancer. If you want a little bit more detail about any of these, maybe check out our previous video where we definitely elaborate on all of these. Yeah, so it's exactly the same between the admin dashboard load balancer and our public load balancer.
Mm-hmm. Yep.
The only difference is that we are not setting up identity aware proxy as an extra authentication layer for this public load balancer.
Got fat fingers, as you can tell. Oh my god. Almost done.
No worries.
So just the SSL cert, I think, and then we're almost good to
Yeah.
go.
SSL, the HTTPS proxy, and for the forwarding rule. So we need to come up with a nice subdomain, I guess.
Yeah. What did we use previously? We had Nomad on Google Cloud. That's awesome.
Yeah, and our other load balancer is on admin.nomad on google.cloud. Yeah, I think public is okay for this demo. I think normally if you deploy like an application or a dashboard or whatever, you would call it app dot or dashboard dot.
Yeah.
Whatever you're building really. For the sake of our demo, I think public is okay.
Actually, I don't think you can use. I'll do this actually because I don't think you can use. Oh. I was going to say I don't think you can use periods in the name.
No, the name you need to either rewrite it or do some string display magic, or just type it out like this. Which I think in a declarative language like HCL is always better because you are being explicit about what you're doing.
No.
You don't want too much programming magic in here.
Exactly. All right. So that's going to be the HTTPS proxy, Google Compute.
Yep.
HTTPS proxy, public.
I mean, with these completely managed SSL certificates from Google, there's really no reason to deploy an HTTP proxy and service. Just make sure you're secure and use HTTPS always.
Exactly. And how do you feel about? So I have a strong opinion on redirecting traffic from HTTP to HTTPS. I'm curious how you feel about it. Do you think it's a good idea to do, or do you think?
I think it really depends on your expected customer base. I think most modern browsers automatically redirect client side.
Mhm.
They make sure that if you're typing in and not explicitly HTTP, that your browser ensures a good security handshake from the start. If you have some older browsers in your client base, you might want to set up an automatic redirect because they might unexpectedly hit an unsecure version of your endpoint.
Yeah.
Which is the last thing you want. So, but we're building a pretty modern stack here. We're all dealing with technology customers, so let's not set up a redirect.
I always try to avoid redirecting by default, only when I think there's the need for it.
Yeah, you get some very unexpected behavior in your browser, especially permanent redirects can really be annoying if you change things in the future.
Exactly, and especially for application to application traffic, I would like to force my clients to use HTTPS, so they don't implement HTTP.
Definitely.
The target is our target HTTPS proxy. Thank you for that, Copilot. I keep typing load balancing schema instead of scheme. It's wired in my brain like that.
I think those words mean pretty much the same thing, right?
Nomad public, and we're here referencing the address that we reserved on the top. Cool. I think this should be it, to be honest.
Looks like a fully fledged load balancer to me, yeah. All right.
Oh, one thing. Just thinking out loud, because I saw the reference when you just scrolled to the SSL certificate. We need to set up the DNS entry into the managed zone.
Indeed, but in order to do that, we need to know our public IP, which is not deployed yet.
Yeah, but we can create the resource already, right? We can create the DNS record set. Here, let me.
We don't know what to put in our data.
I think I do.
No, because this global address has not been deployed yet.
I know, but it has a dependency on it, right?
I'm not sure. We can have a look in our DNS entry.
If you scroll down to the file that I have open now. It should be this. It's simply for the DNS validation of the certificate. Oh.
Yeah, I think this Terraform will ensure everything is deployed in the correct order, so this should work indeed. Yeah.
So why we create the A record is one to route traffic to our load balancer, but also to make sure that the certificate passes its validation. If you create a managed SSL certificate, it needs the A record of the load balancer, a load balancer, or another place where you attach the address to, simply to validate that you for Google to validate the SSL certificate.
Yeah.
And
so it's deploying.
And creating a managed SSL certificate usually takes about 10 to 15 minutes, as we saw in our previous episode. So expect this to travel in time in a brief moment. Yeah. We'll wait until everything is deployed and head over to the load balancing page in Google and take a look at the SSL cert. And if we need to, we'll do some time traveling.
So yeah, there are quite a few resources involved in a load balancer, so it takes a little bit of time. Still nothing too bad.
Yeah. It was a huge shift for me when I went from AWS to Google, where in AWS you have a single resource for a load balancer, and Google it's made up of like 5 to 6 resources. But you'll get the hang of it after you created a couple.
Yeah, so I personally kind of prefer that because you can compose different resources in the way you need them. For example, if you need an HTTP versus HTTPS proxy, or you want to deal with multiple backends, instead of having to type all of that as options in a single resource and causing that resource to change every time you want to update it, you can just stack these resources as layers and sort of compose them instead of having a ton of configuration options on a single resource, which I think is easier to manage.
Yeah, nice way to view that indeed that way. Cool. Let's head over to the Google.
Yeah, we go to load balancing, and we should see two now: our admin and our public. Yeah, there we go.
Ooh, nice.
All instances are healthy, so it can reach our instance group already, and it means that traffic runs as expected, exposing something on port 80 that returns at least a 200 HTTP status code.
Yep.
So very, very nice.
Awesome. Let's check out the certificate.
Yeah.
And I think it's going to be
Yeah, it still
provisioning. Cool.
takes some time.
Awesome. There we go. An active certificate for public.nomad on Google Cloud. Nice. Yeah, let's take a look. I think if you're going to head over to public.nomad on Google.cloud, it should return a 404, I'm going to assume, because there's no default route.
Yeah, there we go.
Nice.
Page not found, which is indeed expected because we don't have any actual service deployed with some tags to tell Traefik to send something to that service on a particular path or subdomain.
Quickly double checking something. Yeah, nice. All right, so that means we're going to set up an example job that actually is going. So we're going to set up an example job, and we're going to make sure that Traefik is able to route us to that example job. Yeah, write out a new job, right?
Yeah, definitely.
Let me create. So it's not a system job, so I'm just going to put it under jobs. I'm just going to call it example.htl for the sake of
Sounds good.
what we're building. Job example. Oh my god, I have so many struggles with it's not formatting it by default, by the way, for me. But that's fine. You might need to help me on the fly with formatting it so it looks appealing to the viewers. And if it's possible, Chris, just provide some context of what I'm doing.
Yeah, for sure. So yeah, we have another job in the same data center. We're not adding the system type here because this is a normal service that we just want to be scheduled wherever it fits, basically. We are adding the spread operator. And that means that with a weight of 100, so that means that Nomad is going to ensure that this service is distributed as evenly across all of our client nodes as possible. If you change this attribute into something else than node ID or change the weight, you get different behavior in the scheduling algorithm. But this ensures basically the best availability, because if one of your client nodes goes down, there's always an instance of the service running on another node. So I think by default, it's a good practice to spread it out across your nodes with a weight of 100.
Yeah. And what is a group in? I just defined a group block, but what is a group in the job specification?
It basically bundles network service and task configuration. You can have multiple groups in a job as well. Like if you have a more complex environment with maybe a server and a worker piece of code, you could put both of these in a job as two separate groups to ensure that, first of all, they are deployed together, but secondly, that you don't have to run these types of things in a single container.
Yep. So I went ahead to create a group block. We put the count on tree. I set up the network in bridge mode. Why do we need bridge mode, Chris?
Yeah, to make sure that we're using a container native networking interface instead of host networking, because we don't want to run out of ports, and we want everything to happen in our virtual network setup, basically.
Yeah, indeed. And port, we define the HTTP port to port 80, so that we are.
It's good to note here that we're only setting the to property, which means the port of the container that we're targeting with our network. We're not setting the value for the port on the receiving end, so basically the host. And that means it will be randomly selected. Traefik can still target this this service in this network, because we're going to add some tags here that basically tell Traefik how and where to find our instances.
Yep. So talking about tags, I'm writing out the service block now. I'm naming it Echo because we're deploying this Echo service. So talking about tags, I'm going to say Traefik enable is true.
Yeah. So this we did not enable Traefik by default. You can do that as well when you deploy Traefik, but we might not want to use this on every service. So I think it's good to explicitly enable it for the services that we are going to put behind our Traefik proxy.
What I'm doing here, maybe you can provide some context on the path prefix.
Yeah, so this basically tells Traefik that we want a route to this service whenever we type /echo in the URL. So we have now our public.nomad on google.cloud. If we postfix it with /echo, that will make sure that that URL is sent to this service and actually hits the container we're about to deploy. And this is a way you can deploy multiple services in your cluster behind different paths. You could also add different rules, so you can route based on not path, but for example, different subdomains or other kinds of properties like HTTP headers and whatnot. If you want to do like version control and different A/B testing, for example. Here we're doing just a simple path-based prefix route.
Yep. All right. Let me write out the server task.
Yeah, so the strip prefixes here is quite important. Once our HTTP call hits our service, we don't want this service to also receive /echo because that might screw up the service's internal route definition. So we just hit our service as if we're hitting like the bare service just slash.
Yeah.
That makes sure we can keep the code in our actual application clean.
Yeah, because so on line 28, let me highlight that. So actually, so on line 27, we're saying if it's a /echo, route it to the echo service. But on 28, we're saying what Traefik actually does, it forwards the entire URI, including the /echo to the service. So we indeed want to strip the /echo when we route it to the service, because we don't expose another /echo in that service. So we set up the middleware on line 28, and on line 29, we're basically attaching that middleware. Okay. Let's write out the task, the server task. So the driver is going to be Docker, and the config is going to be the HashiCorp, HTTP echo.
Yeah, very simple sort of hello world type container just to validate that everything. So we're opening the port on this image again based on our named port up here.
Yeah. Gonna pass in some arguments. We again use that magic port definition because we defined the port. We have a named port here. So that's done. Then pass in text for the service that we want to get back. Let's say hello world from node. We can do some fun stuff here. Node.unit.id. Oh.
Yeah, so what Bruno's doing here is basically setting the text that you will see when you hit the service. It could just say static hello world, but this is a fun little way to actually show that we're doing load balancing to multiple instances on multiple client nodes. And by sort of exposing in the text the node UI ID and the allocation ID of every instance of this task. We can show in the UI when we refresh that we're hitting different VMs, basically.
Yeah, and good to note, so a system job, which we deployed for Traefik, system jobs get deployed to every node in the cluster. But if you scroll up a little bit, Chris, this is not a system job. This is just a job. But we did say in the group on line 10, count equals to 3. So we're expecting this to be deployed on 3 different agents, clients. And therefore, if you scroll down back below to our hello world, we should receive 3 different responses, because it gets deployed 3 different times with 3 different Unix nodes.
Yeah, so in an ideal deployment, each of these would run on a different instance, but it's no guarantee, even with the spread operator in place, because scheduling is always a best effort. Mm-hmm. So if a particular node is already full, it's going to allocate this on another instance.
Yep.
All right, let's copy this over and deploy our job in our Traefik, in our Nomad UI. Again, it's not automated yet with application level CI/CD. We will do that in a future episode because we don't want to do manual labor, of course.
Yep.
But for just demoing that our setup works, it's fine to do this just once. So we actually are getting a little error here. It says that there's something up with a version of our CNI plugin, specifically the bridge networking.
Schedule dry run. This is in the cluster.
So what we could do is go to our client and open it up and see what is actually there in terms of add-ons and plugins. So I do expect CNI to be here. Maybe it's not. It is in our script here, so maybe this step during the boot of the virtual machine.
Yeah, let's double check whether it is actually installed in True Serial Port.
Yeah. So here we can debug the boot logic. Let's go all the way down. Yeah. See where it is.
Error performing RPC to servers. What is that? Not automatically. Yeah.
That's from Nomad. Here we go. So it is booting, and it says.
Gotta love this long line logging. These are all the default arcs passed to the CNI.
So it says it's going to look at opt CNI bin to see whether there are any relevant drivers installed. I think we did that.
I'm curious what the line below is. If this is
here we see an error actually. Yeah. Failed to load CNI during init. No network etc CNI net.d plugin not initialized.
What happened? Okay. Yeah. Did you try turning it on and off again? Cool. So new error that we have not seen before. That's interesting. Let me. I'm not a.
That's
CNI
just
expert.
in Google, right?
Boom, 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 boom.
Mhm.
Let me put some things up. All right, audience, we are just trying to look for a solution. So bear with us meanwhile.
There we go. There was a typo here.
No way. Okay. Was it? What did it say?
Hmm?
What did I type there?
We miss an S here. So
Oh,
it
God.
probably downloaded this whole plugin.
Oh, okay. I'm sorry for that. I was assuming it was /release/download. I do not memorize those things.
No worries. This is why we put everything in codes. It's pretty easy to update and fix now. So this is going to change the instance template, update all the instances in our manage instance group. And then on our new instances, we should actually see also in the metadata that the CI plugin is installed. And when we then schedule our job, everything should work.
Everything should work. Trademark. Nice.
So it's going to take a little bit to deploy, and then it's going to take a little bit to update all the instances in our instance group.
Yep. It's nice that we have just a single Cloud Init file to be able to bootstrap all the agents, whether it's a client or a server. I really like it.
Yeah, the whole setup is fairly simple. It's instance group, Cloud Init, just installing a Nomad binary with some config. I really like that Nomad is a single binary for both servers, clients, and the local command line interface. It's all the same binary.
Yep.
So the whole setup and deployment is much easier than if you, for instance, want to deploy Kubernetes in your own environment.
Yep. Yeah, we try to do that for all of the HashiCorp products. Same for Boundary. We used to have a separate Boundary worker binary, but we actually shoved everything into a single binary.
Very cool. So yeah, our instance groups are updating to a target of 3 instances. We now have 6 because we have 3 new versions, and now the old ones are going away one by one.
Yep.
You can see that these new ones are still being verified, so we need to wait for the first health check to pass.
We typed the exact same thing in Google, searching for that network config that was missing. I can see it on the top of your browser bar. Nice.
Yeah, it's nice that we have all these resources like Google available nowadays, like also to figure out if someone had the same issue before and then fix it really quickly instead of having to spend a lot of time figuring out the problem.
Yeah. Times must have been hard when there was no when those resources were not there. But I guess times were also simpler and less complexity. Okay. Nice. So those instances are sort of being drained, and we spin up new ones.
Yeah.
Cool. Should just take a minute or so. What is your favorite feature from Nomad, Chris?
My favorite feature, I think it's pretty cool that you can not only schedule containers, but also binaries and even Java executables. Or you could even write your own sort of plugin to be able to support any other type of runtime that you might want.
Yeah,
So
nice.
I think it's much more flexible than just being able to run containers. I think that's cool.
Awesome.
So yeah, we have one. All of our new instances are healthy. I think soon they'll be marked as verified as well, and then we should start seeing them appear in the Nomad UI as well.
Yeah. You want to check the serial port logs for the new
Yeah, let's make sure that our new instances actually have the driver properly installed.
that I didn't make another typo.
So here, search for CNI again. Of course, it's going to be in the same location. Still getting an error here.
No way. Is this the same one? Is this what was the timestamp? Oh, it's 2 minutes ago.
Yeah, this is definitely a new VM.
Yeah. Is it still having an error? Failed to load CNI during it, please. Let me double check that I didn't make more typos. So now I'm getting anxious.
Let's have a look if the new clients are properly tagged.
This is download.
As you see a lot of CNI plugin information here, so I think the client is actually okay.
Okay.
We can see the version of CNI plugin being registered. So I think this error that is still here is actually coming from Docker.
Okay.
Because we do install Docker before our CNI plugin. So probably when Docker starts, it can't find this plugin.
Yeah.
But then once the CNI plugin is installed and Nomad is installed, everything is there and it should be good.
Nice. I'm gonna assume the if you go back to the example job, that it's no longer complaining.
Yeah, we have to put that in here again.
Yeah. And again, audience, we're creating the job to the UI because in a future episode we're gonna set up CI/CD for our Nomad job.
Definitely. Let's run a plan. Yeah, everything is okay now. So because we tagged our network here as type bridge, it's going to look for bridge networking, which depends on this container native networking interface plugin. Because it is now properly installed, it can find it, and the scheduling dry run succeeds.
Yep.
So let's go ahead and run this. We expect 3 instances, 3 allocations, ideally on 3 different nodes, but not a guarantee. So let's see what happens.
Nice.
I think because all of our clients still have plenty of room left, I think the distribution is going to be optimal.
Yeah.
All right, that was pretty fast again. 3 allocations running. We can also see in our topology where they are running. So they are on our 3 new nodes. We can see this example job appear. So that looks very good. Let's see if we can actually reach our service, right?
Yeah, sure.
Where did we put it again? I think it was
/echo, I think.
Echo, right? So let's go to our public load balancer, public Nomad on google.cloud, and then /echo, which was the path we specified in our load balancing proxy. And there we go. We get a hello world from node 4b allocation AF. And I think if we refresh now, there's a pretty decent chance that we hit a different allocation on a different node, and these numbers should change. And
yes,
indeed, that's what happens. So we can successfully show that we have multiple instances running, that they're being load balanced behind our proxy, and that this is all exposed through our Google Cloud load balancer.
Nice.
Yeah,
Awesome.
so that basically sums up the whole setup of deploying a public service on Nomad behind load balancing proxy with Traefik on a Google Cloud load balancer with some DNS in front. So this is our entire web stack, basically.
Yeah. This is awesome, Chris. I'm thinking out loud, what are we going to cover in our next episode? So next episode will be episode 4.
Yeah. So we now have a very cool service running, and it tells us hello world, but an actual service to some end users should be a bit more useful, right?
Yep.
And when you want useful services, you want things like people being able to sign in and do all kinds of things that require state, something to be remembered. And in order to store state between instances and between shutdowns, you need some storage. Nomad doesn't come out of the box with storage built in, so we need to deploy some things for that to be able to hook into different types of storage interfaces. I think because we are on Google, to keep it cloud native, it would be cool to deploy a plugin to use Google Cloud Storage as a backend for storing job data.
Yeah, I think that's awesome indeed. And I think there's also a CSI driver that we can use to mount volumes and file systems.
Yeah, there's all kinds of drivers. You can mount Google Cloud storage disk from Compute Engine. You can mount storage buckets. You can mount network file storage. There's all kinds of options.
Cool, exciting. Let's explore that in our next episode. And then I think episode 5 or 6 we're going to focus on metrics and observability and being able to scale our jobs based on those metrics. But I think let's wrap it up for today. As Chris recapped, in episode 1 we set up our compute, we deployed the cluster. In episode 2 we set up a load balancer to expose the Nomad UI. In episode 3, this episode, we set up a load balancer acting as an ingress proxy, which uses traffic to be able to dynamically route us into the cluster, depending on the services that we deploy and certain path prefixes or subdomains, all kinds of routing magic. You can see our Hello World from Node X application is deployed here, the HashiCorp HTTP Echo job. Chris, thank you very much for doing this with me. I'm going to see you in our next episode. Audience, you all have been wonderful. Have a nice day, and we'll see you in episode 4. Cool. Thank you, everyone.
See you. Bye-bye.